Hey everyone, and welcome back. So today we're going to talk about how AI learns, but maybe more importantly, how it fails to learn. It's in those failures that we really start to see the difference between just, memorizing stuff and actually understanding it.
So let me ask you a question. What does a bad student and a bad AI have in common? I know, it sounds like the setup for a terrible joke, right? But the answer? Well, the answer is kind of the key to understanding one of the biggest challenges in all of machine learning. Okay, to get to that answer, we're going to use a simple analogy. Let's call it the student and the machine. Just for a bit, I want you to picture our AI model as a student who's cramming for a huge, super important exam. And here's the thing. For this student, the goal isn't just to nail the practice questions. I mean, anyone can do that. The real goal is to get the subjects so well that they can walk into that final exam and answer any question thrown at them, even stuff they haven't seen before. That's generalization, and that's exactly what we want from our AI. All right, so our student, they can fail in two really different ways. And the first one, it's the one we all know, not studying enough. This is what happens when you're just too simple. So imagine this student, right? They kind of just glance at the book. They don't really get the big ideas, the patterns, nothing. So of course, when the test comes around, doesn't matter if it's practice or the real deal, they just bomb it completely. They just didn't put in the work. So in the world of machine learning, we have a name for this: underfitting. The AI model is basically that lazy student. It's way too simple. It hasn't learned anything meaningful from the data, so it's terrible at everything. It's pretty much useless. And if you look at a graph of an underfit model, it's almost kind of sad. It's like it's trying to draw a simple straight line through a bunch of data points that are clearly making a curve. It just misses the whole point because its whole worldview is, well, it's just too basic. But okay, that's the obvious failure. There's another way to fail that's a lot sneakier. Problem number 2, memorizing the test. And this is the trap of being too complex. And trust me, this one is way harder to catch. Now, this student, they're the complete opposite of the last one. They study like crazy, but, and this is a huge but, they don't actually learn the concepts. Nope. They just memorize the exact answer to every single practice question. So they look like a genius on the practice test, right? Perfect score. But then the real exam comes, asks a question just a little differently, and poof, they're totally lost. They fail. And you guessed it, this has a name too: overfitting. The model is so complex that it's just obsessed with the training data. It knows it too well. So well, in fact, that it's also memorized all the random little blips and noise, all the stuff that doesn't matter. It thinks that noise is part of the actual pattern, so when it sees new data from the real world, it just can't cope. And the graph for an overfit model is wild. At first you might think, wow, this is amazing. It's this crazy zigzagging line that perfectly hits every single data point. It doesn't miss a thing. But look closer. It's created this totally chaotic, nonsensical path. It's completely useless for predicting what comes next. It's learned the wrong lesson. Okay, so if being too simple is a fail and being too complex is also a fail, what are we supposed to do? What's the goal here? Well, the goal is what we were talking about at the start: true understanding. It's all about finding that perfect sweet spot. So let's just recap and put these two side by side. On one hand, you've got the underfit model. Too simple, misses the point entirely, fails at everything. On the other, the overfit model. Way too complex, gets obsessed with noise instead of the real trend. It looks amazing in practice, but falls apart on the final exam. See? Two totally different roads that lead to the exact same place: failure. So what does that sweet spot look like? It's not the lazy straight line, and it's not the frantic zigzag. It's a smooth, kind of elegant curve that perfectly captures the main trend of the data. And notice, it's smart enough to ignore all that distracting noise. It doesn't need to be perfect on every single dot because it gets the big picture. And that right there, that getting the big picture, has a very important name. It's called generalization. Honestly, this is the holy grail of machine learning. It's the ability for a model to do well on new stuff it's never seen before. It's the difference between memorizing and actually learning. So the big question is, how do we get our AI student to do that? How do we steer it towards that awesome generalization and away from the two failure modes? Well, you could say we give it a study guide for machines. And there are a few pretty smart ways to do this. First, you give the student more practice questions, right? For an AI, that just means feeding it more data. You can also teach it to focus on the big picture and not sweat the small stuff. That's a technique called regularization. And finally, you give it surprise quizzes with new questions to see if it's really learning or just memorizing. For an AI, we call that validation. So, what's the big takeaway here? It's that building a good AI is so much more than just dumping a ton of information into it. It's a balancing act. It's a real art. The best models, the ones that really work, are the ones that nail that balance between learning from the past and being ready for the future. And that kind of brings us full circle. So the next time you interact with an AI, when it recommends a song or finishes your sentence, just take a second and ask yourself, is this thing a real learner? Does it actually understand? Or is it just an incredibly good memorizer? Because that difference, well, it's everything.